using integration by parts, integrate e to the 2x sine 3x. So e to the 2x sine 3x. Now they tell us to use integration by parts, so our first thing is, well, what parts do we choose? Now, usually if there's an exponential around, that's a great dv. And that would mean that our v is going to be e to the 2x over 2. So our u should be sine 3x. And our du, it follows, would be cos 3x. Alright, so it's u. Oh, sorry, 3 cos 3x. I felt like there was something wrong there. 3 cos 3x. Alright, so it's u, so sine 3x. And then times v. And then v du. Alright, so let's clean this up a little bit before we continue on. Now remember, the point of integration by parts, I'm going to bring the 3 and the over 2 out. The point of integration by parts is to trade one integral for another that hopefully is easier to solve, something that you already know about. I don't know how to integrate e to the 2x cos 3x any more than I know how to integrate e to the 2x sine 3x. Now for the one we started with, the question suggests integration by parts. Maybe I can do that again here. I'll just copy it back over just so I've got it all on a fresh sheet. But if I'm going to use integration by parts again, what should I choose? Okay. Well, what we don't want to do is undo our first integration by parts. Okay, it's a big mistake a lot of people make. They do uv minus v du, and then they got to do another integration by parts, so they let their v be their new u, and their du be their new dv, and they'll end up with uv minus u dv, and that gets them back to where they started. Okay, everything sort of gets undone. So I don't want to pick for my dv something involving the cos 3x. Unless I have a really good idea of what I'm doing, probably shouldn't do that. So that leaves the e to the 2x, which I would have chosen anyway for my dv. Okay, just like I did before. Now we get the same v here, but what changes is our u. So cos 3x du is going to be 3, I'll remember it this time, minus 3, in fact, minus 3 sine 3x. Oh, and this should, I don't know how that turned into a 3, that should be a 2. Too many constants, that's my problem. Okay, so u, that's cos 3x, v, then minus, okay, and we're going to have our v again. Okay, so that's a lot. Let's write it a little nicer. Let's clean it up a little bit on the next page. So sine 3x e to the 2x over 2 minus, oops, wrong way. Okay, so first the minus 3 over 2 times this, so that's going to be minus 3 cos 3x e to the 2x. The two 2's on the bottom will combine to be a 4. Then minus 3 halves times minus, it's going to be plus 3 halves. And you know what? We're going to bring out the 2 and the minus 3 as well. So it would be plus 3 halves, but I'm going to multiply it by minus 3 on the top and divide by 2 on the bottom. So it's actually going to turn into minus 9 over 4. If you need to go a little slower, of course, go ahead and do that. And then we'll have e to the 2x times sine 3x in here. Now, where have I seen e to the 2x sine 3x before? Well, that's exactly what we started with. So you ask yourself, well, did we just go around in circles? No. And here's how you can tell why. These parts up front, they don't cancel each other out. And we're not just left with one copy of this, we've got minus 9/4. Okay. So here's what we're going to do. We are going to be a little fancy. We're going to say let I be equal to, just to cut down on our writing, because we're not going to do any more integration. We're actually just going to do some algebra. So if I let I be that, what we've shown is this integral is sine 3x e to the 2x over 2 minus 3/4 cos 3x e to the 2x minus 9/4 I. Okay? I'm going to add 9/4 I to both sides. So I plus 9/4 I, that's going to be 13/4. Get a common denominator, check that out. And now what I can do is I can multiply both sides by 4/13. And that will just leave I on the one side. And we could do things like try and, factor out the e to the 2x if we wanted to. I'm comfortable with it the way it is. But you might decide otherwise. Okay. And that just leaves me with my I, and I is exactly what we were looking for. So I suppose the only thing left to do, obviously we're going to need a plus c in a moment, but I could bring the 4 in. On top, 13, 2, oh, I suppose we could cancel, so we can get a 2 here. A 13 on bottom. The 4 and the 4 will cancel. We'll get 3 cos 3x e to the 2x over 13. And we don't forget our plus c. And there we go. We integrated, did integration by parts. We had to do it twice, and we had to be a little clever, introduce a little bit of algebra, rearrange, and simplify to save the day.